In section 2.7, we're going to be talking about absolute values and how to evaluate those, and then also how to get the graph of an absolute value function. Let's first of all look at the formal definition of an absolute value. Now, we normally discuss absolute value as the distance that a number is from zero, but its algebraic definition is defined using a piecewise function, which we've looked at graphing before. So if we have the absolute value of x, it's equal to x if x is greater than or equal to 0, and it's equal to negative x, or the opposite of x, if x is less than 0. So let's talk about that and evaluate a few absolute values. Let's say I ask you, what is the absolute value of 3? Well, remember that what we're going to do is we're going to go back and look at our constraints here on the end, and we're going to see, is our x number greater than or equal to 0, or is it less than 0? Well, 3 is greater than or equal to 0, so this says that the absolute value would be equal to the x number, which would be 3. What if I ask for the absolute value of negative 7? Well, again, I look at my constraints. Is my x greater than or equal to 0, or is it less than 0? Well, it's less than 0 because negative 7 is less than 0. And so to evaluate that, I would do the negative of x, which would be the negative of negative 7, which would be positive 7. Or we could think of that as the opposite of negative 7. And what if I did the absolute value of 0? Well, again, looking at my constraints, 0 is less than or greater than or equal to 0. And so we're going to evaluate it by using just the x value, which is 0. So the absolute value of 0 is 0. So that is actually how we define the absolute value without using just the generic definition of the distance that a number is from 0. Now we're going to spend some time looking at the graph of the absolute value of x. Now say we wanted to sketch the graph of y equals the absolute value of x. So what we're going to do is we're going to make a table of values here. I've already filled in some x values, and let's get their corresponding y values. So if I let x be negative 3, I'm going to get that y is equal to positive 3. If x is negative 2, y is equal to 2. Negative 1 will give us a value of 1. 0 would give us 0. 1 gives us 1. 2 gives us 2. And 3 gives us 3. Now what we're going to do is take a minute and we're actually going to plot those points. So let's look at negative 3, 3. We'll put a dot there. Negative 2, 2. Negative 1, 1. 0, 0. 1, 1. 2, 2. And 3, 3. So what we should see then is that our graph appears to look like a V. So if we connect our points, our graph is going to look like that. And that is what the graph of y equals the absolute value of x looks like. Now let's take a moment and sketch some other functions that are just transformations of the absolute value of x. So if we wanted to graph y equals the absolute value of x plus 2, we talked about earlier in the last section that if we have f of x plus a number d, that number on the end is going to be how much we shift up. So what we're going to do is take our graph of y equals the absolute value of x, which we know is our v, and we're just going to shift it up 2 places and then sketch the graph from there. Now, what about the graph of y equals the absolute value of x plus 3? So this time we have the plus 3 inside of our absolute value, which is similar to having it inside of parentheses. Well, remember also that we talked about that if you have f of x plus c, that's going to be a shift to the left. Remember that when it's inside the parentheses, you always go the opposite direction of what you have. So we have a plus 3, so we're going to shift to the left 3 units. So we're just going to take our v and we're going to shift everything over to the left 3 units. So then we would get something that would look like that. Now let's look at a combination of a couple transformations. So here we have the absolute value of x minus 1, which we know is a shift to the right because we're inside the parentheses, or the absolute value in this case. So we're going to go the opposite direction. We're shifting right 1. And the minus 4 on the end means we're going to go down 4. So let's shift to the right 1 and down 4. If we draw our graph from there, we get something that resembles that. Now what about the graph of 2 times the absolute value of x? Well, I'm going to go back and just kind of very lightly sketch in the absolute value of x. So remember, it went 0, 0, 1, 1. We'll get some points on here. 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. So that looked something like that. But then when I do 2 times that value, remember that we talked about that that's going to be a vertical stretch of our graph. And so now our points are going to go to, instead of 1, 1, our y value is going to get doubled to 1, 2. So we'll have 0, 0, 1, 2. 2 used to be at 2, so now it's going to be at 4. 3 is going to be at 6. Negative 1 is going to be at 2. Negative 2 is going to be at 4. And negative 3 is going to be at 6. So we can see that we are actually stretching our graph vertically and making it steeper. Now let's take a moment to look at what we call the general form of an absolute value function. Our general form looks like this: y equals a times x minus h plus k. We call the point hk the vertex, and then we also have an axis of symmetry, the line x equals h. That would be a vertical line. So let's go back and just very quickly look at what we did with y equals the absolute value of x. When I had that graph, make sure we understand what we're talking about here. So the absolute value of x looks like that. And this point here at the bottom is your vertex. So that point at 0, 0 is what we call the vertex. And then if you'll notice, in this case, the y-axis is the line, or the axis of symmetry, because it's dividing my graph right through the middle. So then we would have this line, which happens to be x equals 0, as our axis of symmetry. Now let's apply what we just did and find where our vertex and axis of symmetry is for the following graph, and then also determine what transformations have been done on this graph. So how have we transformed our parent function? So first of all, our vertex, if we go back, we want to have a absolute value of x minus h plus k. Well, notice that we have x plus 2, so that's going to be the same thing as minus negative 2, because our formula, if we think of it as a formula, says we have to have x minus a number and then plus k, but minus 1 on the outside is the same thing as plus negative 1. So then we could say that our vertex would then be, once we've got it in this form, at the point negative 2, since that would be my h value, and there would be my k, so my vertex would be at the point negative 2, negative 1. And then my axis of symmetry, we'll abbreviate that, is a vertical line at x equals, and it's just your x value for your vertex point. So it'd be x equals negative 2. So if I think about the graph, then we can discuss what we've done to it actually as we're graphing it. Our graph is going to look like, let's get our axis on here. Our graph is just going to look like our absolute value graph, that's been shifted to the left 2, down 1, and then that factor of 3 will stretch it. So this is going to go over 2, down 1, and put my vertex. Notice that that's where we had the vertex labeled, was at -2, -1. And then we're going to stretch it by a factor of 3 because we multiplied by 3 in the front. And then we also should be able to notice that our axis of symmetry would be this line through x equals -2. So we have moved left 2, down 1, and then done a vertical stretch with a factor of 3. We're going to wrap this lesson up by coming up with a formula or an equation for the absolute value that we have shown here. So let's first of all find our vertex. So our vertex, notice, is at -1, -2. Notice also that I can use my graph to help me find what A is by looking at the slope. So if I start here and count to here, that's going to tell me that I'm going to need to go up 1, 2, 3, and over 1, which would be what my A value is. So my slope should be 3. So my equation becomes, remember we're looking for this general form, so my equation becomes 3, absolute value of x minus -1 plus my k, which was -2. So just rewriting that, cleaning it up a little bit, we get x plus 1 minus 2.